What I have here is the version 3 revision 1 prototype board, or the version 3.1 board, or the prototype 3.1 board. I don't know. I'll give it a name at some point. Hey everyone, Chef Tom here, and welcome to episode 6 of the 65816 ATX project, or as I like to call it, Project Neon Sunrise. And I think when it gets to GitHub, it'll be called the NS816, since I seem to see everyone else call their homebrew computers their initials -6502, but I don't plan on staying with the 6502. And I don't plan on using my initials, because I hope this will become a bigger project than just me someday. This week, I struggled a lot with getting through one particular little problem, and I think you're going to enjoy seeing it. But this all starts with getting the board built, so let's start there. Today's goals also include testing the Hello World program that's already stored in the EEPROM, because the base LCD connections should still be the same and it should just drop and run, as well as starting to work on the serial monitor in earnest, since the ACIA should be working properly now. So like any good soldering project, we'll start by putting the lowest components in first. On this board, that would be the 240 pin, 228 pin, the 24, and 4 14 pin sockets. Oh yeah, and this DIP 14 designed for a full can oscillator. Even though I've hit all of these sockets with my pin straightener, some of them need a little help getting into the board. Once I get all the bigger sockets into the board, since I know they're going to be kind of stuck a little bit with friction, I flip it over and start soldering. Then I just solder 2 opposite pins on each socket so that I can check and make sure it's flush before I fill in the rest. The pins for the socket for the oscillator are so short, I just did all 4 of them. And we'll do the same with all the DIP 14 sockets. I opted to put the 555 timer directly in the board as opposed to a socket, so that I can use my 555 on a can timer, which means I need it to have a lower profile. This 330 ohm resistor happens to already be sitting right here on my bench, so I'm just going to put it in. Looking at this footprint, I could potentially go to a smaller resistor footprint in the future. I just took out the drawer of 0.01 microfarad caps because I use one on every chip as a decoupling cap. Well, I'm trying to put these 22 picofarad capacitors in for the ACIA, and the footprint actually needs to be wider, not narrower like it does on the resistors. So I still have a couple of design changes to make in the next revision. I've still got the 3 vertical resistors here, and then the decoupling cap that goes with the ZIF socket is going to have to be mounted to the back of the board because it's in the way. I didn't give enough clearance for the capacitor. I've added the header for the LCD, and now I'm adding the 7 radial capacitors. We're really starting to get through the soldering now, putting in the DB9 port and flood filling the posts to give it some extra rigidity. At this point, it's just a matter of mounting the 1.834 MHz can, the USB port, and double checking that everything's soldered in right. So not only did I not leave enough space for the capacitor and I have to mount that on the bottom, not as big a deal because it's going to have standoffs, but the amount of space I left for the handle isn't enough, and I'm going to have to mount it upside down, which is something I was trying to avoid. And with that, it's time to move all our components over from the V2 board and give it a test. And nothing. Alright, so I've been trying to diagnose this for a while with my multimeter, and I am not getting anywhere. I am getting a reset signal, and I am getting a clock signal, so I'm not sure what else is going wrong. I put the 555 in a can, the 555 drop-in timer in, so I have some control. And it's definitely going through the startup sequence. I just don't know what's wrong. There's something very, very wrong. I just don't know what it is. I'm confused. And I'm going to call it a night because I don't know what else to do right now.
One eternity later.
Excuse the mess on my desk, but apparently if I drop the power to 4.7 volts instead of 5, I will get the hello world message, which is all I wanted. Can't explain that one. And this brings us to a new segment I'm calling WTF Moments. Moments that really made me scratch my head. The first one was, why does it act like it's vectoring to the NMI on startup instead of the reset vector? I could not figure this out. There was some debate whether I had my address lines crossed, because if I had A0 and A1 inverted, then, or A1 and A2, then it would read the wrong address, but look like it was reading the right address. That wasn't the case. Honestly, we have no idea, but it wasn't, except that it was, and let me explain this. It would start up, initiate the first instruction, and then trigger an NMI. And even though I don't know what was triggering the NMI, the line was never pulled low, I could not figure it out. Again, until I turned the power down to 4.7 volts just because I wanted to see if, I don't even remember what got me to do that, but I decided to pull it down to 4.7 volts, and all of a sudden it stopped triggering the NMI. So I don't know what's up there, but I can't use the USB port because I can't control, well, I have to make an adapter to control it. So right now you see I have the power. You can actually see on the board behind me, I have the power running directly into the breadboard. So for our next steps, we're going to start working on the serial interface in earnest. That will be basically the bulk of the next episode. I have some prototype code already written, but I've never really been able to test it properly. The hardware side, the next step is still to design the real-time clock circuit. Again, we haven't moved on that. That's just the next hardware step. And hopefully we'll start getting caught up to where I thought I'd be by now. I have been kind of playing with some designs for the 65816, but I'm saving a lot of that till we get this down and running and working. I want to have all the code working in 6502 mode before we try to do anything with the 816. Because it can and does start in native 6502 mode, the easiest thing will be to design the board and drop it in and see if the code still works. And if it does, then we can move on to using some of the advanced features of the 816. So this one's been a little frustrating, but a good learning experience, and I'll see you next time.